Well, stat students, we're about ready to start a new adventure of online learning. So I'm going to introduce chapter 6, which is continuous probability distributions. The main continuous probability distribution that we're going to be learning about this chapter is the normal probability distribution. But there is another continuous probability distribution that we're going to start with called the uniform probability distribution. And we're going to use this as an example to kind of get started to look at how a continuous distribution looks. So if you guys are home and you want to bring up StatCrunch, we're going to be using StatCrunch to help with demonstration of this. So in StatCrunch, we can use the uniform probability distribution and a normal probability distribution. We're going to find that in stat calculators, and we're going to start with the uniform one that's going to be down here. So again, we're going to be in stat calculators and uniform. The uniform probability distribution looks like a rectangle. All of the probabilities are the same for any level of outcome. Here we have our random variable from 0 to 10, and those are just numbers that you can pick. This could represent number of hours it takes to do something, for example. And so what happens is that the area under the curve, if we actually look at from 0 to 10, the area under that rectangle has a probability of 1. And you can see that down here in the lower left corner. So the area of this rectangle is 1, which makes sense because the sum total of all of our probability outcomes is equal to 1. So the probability of getting any number in here is equal to 1. Also, if we want to look at the probability of our value is less than or equal to 0, we're going to come up with a probability of 0 here as well. And so now we can look at what is the probability of a value that's going to be less than 2. And we can see that that probability is actually going to be 0.2, which makes sense because if we look at 0 to 2, that's a value of 2. We multiply that by 0.1. 0.1 times 2 is equal to 0.2. We're literally doing the geometric formula where we're doing width times length. Okay? And so if we wanted to do what's the probability that's less than or equal to 4, we're going to increase the size of a rectangle. We're going to double the size that we have. It's going to go from 0 to 4, and it's going to be 0.4, 40%. The nice thing about this calculator is that we can actually flip this inequality around. We can do greater than or equal to 4, and we can see from 4 to 10, that represents 6 values here, a difference of 6. 6 times 0.1 is going to be 0.6 down here. We can also calculate values in between any two values. This is the example that pops up immediately. That's the probability that a value is between 3 or 7. Well, the difference between 3 and 7 is 4, and 4 times 0.1 is going to be 0.4. And so we can use this uniform probability distribution calculator to find these probabilities. What we can also use it for, however, and this will work with a normal distribution as well, is we can ask the question, what value gives us 0.35? And we can type in our probability here, and it'll backwards calculate it to a value of 3.5. Or I could say, what is the 88th percentile value? I could type in 0.88 here. I hit compute, and we can see that at 8.8, 88% of our probability is less than 8.8. If you're going to find percentiles, you always want to go probability values to the left. So you'd want to use this less than or equal to inequality. If we use between, we can also type in a probability here. The deal is that will always split the difference right down the middle, and will leave equal areas that it's not counting on both sides. Here, I'm using a value of 90%. So we're going to have 5% down here, or 0.05 probability, and then this white part over here will also be 0.05 probability. So that's how you use the uniform probability calculator.